Hello everyone, I am Salik by Siti Aisha, third year student from Cotabato State University, Bachelor of Technology, Livelihood and Education. And for this video, let's discuss about...
So I have here example number 1. Professor Gwen conducted a test to her 10 students in elementary statistics class, twice after 1 day interval. The test given after 1 day is exactly the same test given the first time. Scores below were gathered in the first test or FT and second test ST. Using test-retest method, is the test reliable? Show the complete solution. So I have here the table. So we have students, 10 students, and here are the scores for the first test of 10 students and the scores for the second test of 10 students. So we have here student 1 got 36 for the first test and 38 for the second test. Student 2 got 26 for the first test and 34 for the second test, and so on. Okay, so using the Pearson and R formula, we will find the summation of x, summation of y, summation of xy, and summation of x squared, and also summation of y squared. So we have here the table for students 1 to 10, 10 students. So our n is equal to 10. So FT, we will have x for FT and y for ST. So FT is the first test, scores of student for the first test, and ST are the scores of students for the second test. So we will get the summation of x. So we will just add 36 plus 26 plus 38 plus 15 and so on up to 35. So the result will be 274. For the summation of y, so all we need to do is to add 38 plus 34 plus 38 plus 27 up to 38. So the summation of y is equal to 316. So to get xy, all we need to do is to multiply x, okay, in this case 36, times y, which is 38. So 36 times 38 is 1,368. So for the second student, 26 times 34 equals 884. For the third student, 38 times 38 equals 1,444, and so on. Okay? So if we will just add all of this, the result is 9,192. So therefore, the summation of xy is equal to 9,192. For x squared, so we will just multiply x to itself twice. So we have here 36 times 36 equals 1,296. 26 times 26 equals 676. 38 times 38 equals 1,444, and so on. So if we will just add all of this, the result of summation of x squared will be equal to 8,332. For y squared, so we will just multiply 38, okay, in this case. 38 times 38 is 1,444. 34 times 34, 1,156. 38 times 38, 1,444, and so on. So if we will just add all of this, so the summation of y squared is equal to 10,400. So we will use the Pearson product moment correlation coefficient formula. Okay, this one, I already discussed the meaning of this in our previous video, validity coefficient. So I will proceed now in substitution. So our n is equal to 10. So we will just substitute. Summation of xy is equal to 9,192, okay, minus summation of x is 274 times summation of y, which is 316, over the square root of, okay, our n is 10, okay, summation of x squared is 8,332, minus summation of x, which is 274 quantity squared, times our n, which is 10, times summation of y squared, which is 10,400, okay, minus summation of y is 316, okay, quantity squared. So we have 10 times 9,192 is 91,920 minus 274 times 316 is 86,584. Okay, over the square root of, okay, 10 times 8,332 is 83,320 minus, so we have here 274 squared means 274 times 274, it is equal to 75,076. Okay, times 10 times 10,400 is 104,000. Okay, minus 316 times 316 is equal to 99,856. So 91,920 minus 86,584 is equal to 5,336 over the square root of, so if we will subtract this, it is equal to 8,244. If we will subtract also this one, so we will have 4,144. So copy 5,336. Okay, so 8,244 times 4,144 is 34,000 or 34,163,136. So we will just copy 5,336, okay, over the square root of 34,100 or 34,163,136 is equal to 5,844.92. So 5,336 divided by 5,844.92 is equal to 0.91. So for the analysis, so the reliability coefficient using the Pearson R is equal to 0.91, which means that it has a very high reliability. So we will use the level of reliability coefficient for this. Okay, so the scores of the 10 students conducted twice with 1 day interval are consistent. So hence, the test has a very high reliability. So let's proceed to our example number 2. Professor Glenn conducted a test to his 10 students in his mathematics class 2 times after 1 week interval. The test given after 1 week is the parallel form of the test during the first time the test was conducted. Scores below were gathered in the first test or FT and the second test or parallel test PT. Using equivalent or parallel form method, is the test reliable? Show the complete solution using the Pearson R formula. So I have here the table. So we have 10 students. So here are the scores of 10 students for the first test, and here are also the scores of 10 students for the parallel test or the second test. So student 1 got 12 for the first test and 20 for the parallel test. Student 2 got 20 for the first test, 22 for the parallel test, and so on. So using the Pearson R formula, we will just find the summation of x, summation of y, summation of xy, summation of x squared, and summation of y squared. Okay, so here's the table. So we have here n equals 10 because we have 10 students. Okay, so x will be, ft is your x and pt is your y. So we have here the score of first student or student number 1 for the first test is 12. For the parallel test or y, it is 20. For the second student, the score for the first test is 20, and for the parallel test is 22, and so on. So to get the summation of x, all we need to do is to add all of this, 12 plus 20 plus 19 plus 17, and so on up to 21. So summation of x is equal to 190. So for summation of y, all we need to do is to add 20 plus 22 plus 23 plus 20 and so on up to 24. So summation of y is equal to 216. So to get xy, so all we need to do is to multiply the value of x here. In this case, for student number 1, we have 12. X is 12 and y is 20. So 12 times 20 is equal to 240. 20 times 22 is 440. 19 times 23, 437, and so on. We'll just multiply x and y. So to get the summation of xy, so same method. For the summation, you have to get the total of this. So the result is 4,174. So for x squared, so we will multiply 12 by itself. 12 times 12 is 144. 20 times 20 is equal to 400. 19 times 19, 361, and so on. So to get the summation of x squared, you will just add 144 plus 400 plus 361 plus 289 up to 441. So summation of x squared is equal to 3,754. For y squared, so you are going to multiply, in this case, 20 times 20, 400. 22 times 22, 484. 23 times 23, 529, and so on. So if we will get the total of this, all in all, summation of y squared is equal to 4,724. Okay, let's proceed in the substitution. Okay, so we have here the Pearson product moment correlation formula, coefficient formula. So let's have n equals 10. So we have here n equals 10. Okay, summation of xy, 4,174. Okay, minus summation of x, which is 190, and summation of y, which is 216, over, okay, we have here the square root of, n is 10, times summation of x squared is 3,754, okay, minus, okay, summation of x is 190, quantity squared, okay, times n, which is again 10. Summation of y squared is 4,724, okay, minus summation of y is 216, quantity squared. Okay, so 10 times 4,174 is 41,740, minus 190 times 216 is 41,040. So over the square root of, we will just multiply 10 and 3,754. So we have 37,540. Okay, minus 190 times 190 is 36,100. Okay, times 10 times 4,724 is 47,240, minus 216 times 216 is 46,656. So if we will subtract this, we will get 700. Okay, over. So if we will subtract this one, so we have 1,440, and we will subtract 47,240 minus 46,656. We got 584. So we'll just copy 700. So we have square root 1,440 times 584 is 840,960. So the square root of this is 917.04. So 700 divided by 917.04 is equal to 0.76. So for the analysis, so the reliability coefficient using the Pearson R is equal to 0.76, which means that it has a high reliability. So the scores of the 10 students conducted twice with 1 week interval are consistent. Hence, the test has a high reliability. Let's proceed to example number 3. Professor Edwin Santos conducted a test to his 10 students in his chemistry class. The test was given only once. The scores of the students in odd and even items below were gathered. O for odd items and E for even items. So using split half method, is the test reliable? Show the complete solution. So we have here the table. For odd, we have X, and for even, we have Y. So the scores of students for odd items and for even items. So we will use the formula of Spearman Brown formula. So we have here the reliability of the original test is equal to 2 times reliability of the correlation of odd and even items divided by 1 plus the reliability of the correlation of odd and even items. So to find the reliability of the whole test, so we will find the summation of x, summation of y, summation of xy, summation of x squared, summation of y squared to solve the reliability of the odd and even test items. So we have here the table. So here are the scores of the students in the odd items and the scores for the even items. Okay, so we have here, we will just add all of this, 15 plus 19 plus 20 plus 25 up to 18 to get 200. So the summation of x is equal to 200. For y, again, we will just add all of this, 20 plus 17 plus 24 plus 21 up to 17. So summation of y is equal to 211. For xy, so we will just multiply the x here and then the y. So 15 times 20, 300. 19 times 17, 323. 20 times 24, 480, and so on. Okay, to get summation of xy, so just add 300 plus 323 plus 480 and so on up to 306. So summation of xy is equal to 4,249. For x squared, so we have 15 times 15, 225, 19 times 19, 361, 20 times 20, 400, and so on. So we will just add all of this to get the summation of x squared is equal to 4,096. For y squared, so we have 20 times 20, 400, 17 times 17, 289, 24 times 24, 576, and so on. So we will just add all of this. So the summation of y squared is 4,533. So we will just substitute, okay, in this formula. So our n is 10 because we have 10 students. Okay, summation of xy is 4,249 minus summation of x is 200. Okay, 200. Summation of y is 211. Okay, over the square root of our n is 10. Then summation of x squared is 4,096. Okay, minus our summation of x is 200 squared. Okay, times n, which is 10. Summation of y squared is 4,533 minus summation of y is 211 quantity squared. So we have 10 times 4,249 is 42,490 minus 200 times 211 is 42,200 over, okay, square root of, so 10 times 4,096 is 40,960 minus, so 200 times 200 is 40,000 times 10 times 4,533 is 45,330 minus 211 times 211 is 44,521. So if we will subtract this, so we have 290 over, if we will subtract this, so we have 960, and if we will subtract this also, we have 809. So copy 290, so square root, 960 times 809 is 776,640. The square root of this is 881.27. So 290 divided by 881.27 is 0.33. Find the reliability of the original test using the Spearman-Brown formula. So we have here the Spearman-Brown formula. So we will just copy 2, and then the result is 0.33. So we will just substitute it here. Okay, over 1 plus 0.33. So 2 times 0.33 is 0.66 over 1 plus 0.33 is 1.33. So we have here 0.50. 0.66 divided by 1.33 is 0.50. So for the analysis, the reliability coefficient using Spearman-Brown formula is 0.50, which is questionable reliability. Hence, the test item should be revised. Let's proceed to example number 4. Miss Caitlin administered a 40-item test in English for her grade 6 pupils in Miagao Central Elementary School. Below are the scores of 15 pupils. Find the reliability using Tudor-Richardson 21 or KR21 formula. So in the table, we have here 15 students and also their scores. Okay, before we use the formula of KR21, we will solve first the mean and the standard deviation of the scores using the table below. So we have 15 students, so n is equal to 15. So these are the scores of 15 students. So to get the summation of x, so all we need to do is to add 16 plus 25 plus 35 plus 39 up to 39. So the summation of x is equal to 405. So for x squared, so we will just multiply 16 times 16, 256, 25 times 25, 625, 35 times 35, 1,225, and so on. So if we will get the total of this, the result will be summation of x squared is equal to 11,970. We have here the standard deviation formula. S squared is equal to n times the summation of x squared minus summation of x quantity squared divided by n times the quantity of n minus 1. So applying the formula, so we have, so n is 15, so we'll just have 15. Okay, summation of x squared is 11,917. Okay, minus, so summation of x is 405. Okay, quantity squared over n, which is 15, times n. Okay, 15 minus 1. So x squared, s squared is equal to, if we will multiply 15 by 11,917, we'll have the product of 178,755 minus 405 times 405 is 164,025 over, so we will copy 15. 15 minus 1 is 14. So if we will just subtract this, we have 14,730. 15 times 14 is 210. So we will divide 14,730 divided by 210. So we have here the standard deviation is 70.14. For the mean, so the formula is summation of x over n. So summation of x is 405, okay, divided by n, which is 15. So 405 divided by 15 is equal to 27. So our mean is equal to 27. So we will solve for the reliability coefficient using the Tudor-Richardson 21 formula. So we have here k over k minus 1 times the quantity of 1 minus the mean times k minus the mean over k s squared. So k here is the number of item. Okay, the x bar here is the mean, and then s squared is the standard deviation. So we have here k, since Miss Caitlin administered a 40-item test in English class. So we have here k equals 40 over 40 minus 1. Okay, times 1 minus, our mean is 27, times 40, our k is 40, minus our mean, which is 27, over, our k is 40, and then s squared is 70.14. So we will copy 40. 40 minus 1 is 39. Okay, we'll copy this. So 40 minus 27 is 13. Okay, so we'll just copy 40 and 70.14. So 40 divided by 39 is 1.03 times 1 minus 27 times 13 is 351 over 40 times 70.14 is 2,805.60. So we have here 1.03. So we will have 351 divided by 2,805.60 is 0.1251. So we will subtract it from 1. So we have 0.8749 times 1.03 is equal to 0.90. So for the analysis, the reliability coefficient using KR21 formula is 0.90, which means that the test has a very good reliability, meaning the test is very good for a classroom test.